Hi everyone, for this question you see the function is defined here as piecewise function and we need to find the value of h if the condition here is limit when x approaches 0 of the function is as is. When we get piecewise function, first of all we will draw the interval so that we know that okay from the domain here less than 0 we know that this is x squared over modulus x. More than 0 it will be in the function 1 plus e 2x over ex minus 1 plus h. And you notice here, our function here involve modulus function. So modulus function, when we're doing limit, we need to identify this modulus function, which is the function in piecewise form selected in this region. As modulus function, it can be expressed in piecewise also. So to express the modulus in piecewise, it will be one function positive when this is greater equals to 0, and this function will be negative if this function will be less than 0. So piecewise function, modulus function, it actually is a piecewise function. Select the correct function according to your region. So your modulus x here is sitting in the interval less than 0. Less than 0, which means that this modulus function is represented by negative x. This is the correct modulus function in piecewise form less than 0. So we cannot use modulus x in calculate our limit. We must select the correct function. Then only we start to find the value of x. We say the limit of the function is as is. Limit for the function is as is means when x approaches from the left-hand side of the function, it will be equals to the limit when x approaches 0 from the right-hand side of the function, so that this indicates that limit is as is. So from that information, we select our function here. When the x approaches 0 from the left, it is a function x squared plus x. With this modulus x represent in the piecewise in the interval less than 0, which is negative x. And this one, x approaches 0 from the right hand side, our function is 1 plus e 2x over ex minus 1 plus h. Now we're going to simplify our limit so that we can find out what is our h here. Substitute 0 inside, I can notice here I get 0 over 0 IDF, which means something I need to factorize and simplify the factor. So I take out the x. Alright, take out the x, factorize the x. So your factor of IDX that make you 0, 0 is x. So you cancel, you simplify that x. And this right hand side, when I substitute 1 plus e0 minus 1 plus h, this is 2, 1 minus 1 plus h, this is 0, so 2 over 0, and very obvious, our function here haven't simplified here because we have two terms here. We haven't simplified our function. What can we do is we try to simplify it into a single function here so that we can solve this problem. Alright, so for this question, we need to do some correction because our function here, we need to do some adjustment on the function, correction on the function. Please correct your function. At right hand side, this is supposed to be negative. Alright, do the correction here. This is supposed to be negative. Then only we can simplify. Alright, so this one is a square minus b square form 1 minus e 2x. When you want to factorize, it will be a plus b, a minus b. So it will be 1 minus square root of this, it will be ex. So it will get e 2x. Therefore, when I factorize this, there is 1 minus ex, 1 plus ex, And from the denominator, we can notice here, we can simplify, take out the negative, you will get 1, take out the negative, minus EX, and plus H. So now you can notice here, the factor of 1 minus EX can be simplified. Now we recalculate, we evaluate this limit again. Substitute 0 inside, we get negative 1. This one substitute 0 inside, 1 plus E0 over negative 1 plus H. So E0 is 1, 1 plus 1 is 2. This is negative 2 plus H. Therefore, H, remove it, plus 2 will become equals to 1. Therefore, our final answer is H equals to 1.